Perfect. Let's go over the theorem, properties of inner products. If you have three vectors like u, v, and w, and suppose you have inner product space V. What's the meaning of that? It means that you have a vector space that has an inner product function. And suppose C is any real number. Then the inner product between 0 and V is equal to the inner product between V and 0, and it is equal to 0 as numerical value. 2. The inner product between u plus v and w can be written as the inner product between u and w plus the inner product between v and w. 3. The inner product between u and cv is equal to c times the inner product between u and v. Definition of length, distance, and angle when it comes to function, inner product function. Suppose u and v are vectors in an inner product space like V. Then the length or norm of vector u, which is defined as the norm of u, is nothing but the square root of the inner product between u and u. The distance between u and v is d. U and v represent the distance between u and v, which is going to be the norm of u minus v. The angle between two non-zero vectors like u and v can be found using cosine theta, which is the inner product between u and v divided by the magnitude of u times the magnitude of v. Now, please note that we are imposing the condition that theta is bounded between 0 and pi. Two vectors in the inner product space V are called orthogonal if the inner product between them is equal to 0. With these properties, consider the vector space of polynomial functions of degree n and less. In this vector space, we can define an inner product function this way. The inner product between two polynomials p and q is defined as you're going to just multiply the very first coefficients, constant coefficients, a sub 0, b sub 0, plus, then you're going to multiply the coefficients for x, plus, you're going to multiply the coefficients for x squared, and you continue this process. And finally, you multiply the coefficients for x to the n. Then you're going to add these together. This is an inner product function on the vector space of all polynomials of degree n or less. Well, consider these three polynomials. P of x is 1 minus 2x squared. Q of x is 4 minus 2x plus x squared. And Rx is x plus 2x squared. Again, we are in the vector space of all polynomials of degree 2 or less. Indeed, it is a vector space. And this function is an inner product function on this vector space. So question says, hey, find the inner product between P and Q, find the inner product between Q and R, find the magnitude or norm or length of Q, find the distance between P and Q. The inner product of P and Q is defined as a sub 0, b sub 0, plus a sub 1, b sub 1, plus a sub 2, b sub 2, which is basically 1 times 4 plus 0 times negative 2 plus negative 2 times 1, which is 2. So this is the inner product between two polynomials P and Q. The inner product of Q and R with the same logic, you're going to just multiply 4 and 0. Why 0? Because the constant term here is 0. Then -2 and 1, 1 and 2. So that's how you end up with 0. The inner product of Q and R is 0. So it means that Q and R are orthogonal. Again, since the inner product between Q and R is equal to 0, so it means that they are orthogonal. The length of Q is defined as the square root of the inner product between Q and itself, which is the square root of 4 squared plus -2 squared plus 1 squared. This is a sub 0, this is a sub 1, and this is a sub 2. So you take each coefficient and raise it to the second power and add them all together. It is equal to square root of 21. So the length of this polynomial is square root of 21. And D says, what is the distance between these two polynomials? The distance between P and Q is the norm between P minus Q. Well, if I just do the subtraction between P and Q, it is 1 minus 2x squared. This is my P. And this is my Q. 4 minus 2x plus x squared. So when I do the subtraction here, I end up with -3 plus 2x, -3x squared. So I'm going to take each one of these coefficients and raise them to the second power, add them together, and I get square root of 22. So the distance between these two polynomials is equal to square root of 22. In this example, question says, use the inner product defined below for these two functions on the vector space of all continuous functions between 0 and 1. So the question says, hey, the inner product that I want you to use is this function, the definite integral of f times g. It gives us f and g, and it says, hey, find the length of f, then find the distance between f and g. Okay, so let us take a look at it. Here, f of x is equal to x, so the norm of f is equal to square root. Remember the definition from here. The norm of u is equal to square root of the inner product of u and u. So if I raise both sides to the second power, you can get rid of this square root. Sometimes it's easier to work with this symbol, or you can just write it this way. Both of them are absolutely fine. So the magnitude of f to the second power is equal to inner product of f and f, which is equal to the definite integral 0 to 1 of f times f. But remember that f is equal to function x. So this is equal to the definite integral 0 to 1 of x squared dx. Going back to calculus, you have a third, x to the third, 0 to 1. So you have a third minus 0, or just a third. But note that this is the magnitude of f to the second power. So the magnitude of f becomes square root of a third, or 1 divided by square root of 3. So the length of this function using inner product is 1 over square root of 3. Now, let us find the distance between f and g using the inner product given to us. The distance between f and g is the magnitude of u minus v, or the magnitude of f minus g. But the magnitude of f minus g, going back here, is equal to square root of the inner product between f minus g and f minus g. Or if you raise it to the second power, it becomes the inner product of f minus g and f minus g. So here we go. It is equal to the definite integral 0 to 1 of f minus g times f minus g, or f minus g to the second power, which is equal to the definite integral 0 to 1 x minus x squared to the second, or the definite integral of x squared minus 2x cubed plus x to the fourth dx. We're going back to calculus, everyone. This is a third x to the third minus 2/4 x to the fourth plus 1/5 x to the fifth, 0 to 1. If you do the substitution, we get 1/30. So the distance between these two functions in the vector space of all continuous functions between 0 and 1, inclusive, using the inner product definite integral of f times g, is equal to 1/30.